Good afternoon, everyone, and welcome to Taco Tuesday. Today's topic is going to be a deep dive into Taco's SKV and SKS pumps presented by Brett Zerba. I'll be your moderator today. For those of you that don't know who I am, my name is Rich Medeiros. I'm one of the engineers and trainers here at Taco. A little bit about Taco, for those of you that may not be familiar, we are a privately owned company, been in business over 105 years now. It's currently owned and operated by John Hazen White Jr., and our global CEO is Cheryl Merchant. We have not only the factories in the United States, but we have factories in, I want to say, Vietnam, Italy. Brett, can you think of some others out there?
Poland, Canada,
Oh, that's right.
Czechoslovakia.
Yeah, we're growing like leaps and bounds. So I'm not going to spend a lot of time on the introduction today. Turn it right over to Brett so he can get started. We do have a handout which you can download. And again, it's on SKV SKS Self-Sensing is the name of the PDF document. And the other thing is that we want to make sure everyone can hear us and see us. So on the questions, if you could just take a second and wave your hands or say hi, you can hear us okay. That would be a thumb. I got a thumbs up, several thumbs up. So it sounds like we're broadcasting. Broadcasting is always a mystery to me, Brett. I feel like sometimes we're talking into a blank screen. But I'll be monitoring your questions today, and I'll ask Brett to pause periodically so that we can answer your questions in real time. So enough of that detailed information and housekeeping and the download. Brett, why don't you introduce yourself and take it away?
Thanks, Rich. Appreciate that introduction. Hi, everybody. Brett Zerba, trainer and applications engineer with Taco, approaching 29 years, and it'll be in October. Almost a third of Taco's existence, right? Almost quarter or a third. I don't know, whatever number you want to talk about it. But it's been a fun ride, that's for sure. So I'm gonna get right into spending kind of talking about the mechanical part of it and get into the drives and whatnot of the Taco SKV SKS pumps. Other manufacturers offer similar technology. We have chosen to call it self-sensing, and that's just us. And I'm not sure exactly what some of the other folks call it, but there is competitors out there that offer this technology as well. But the green one's the best. I do work for Taco, that's why I said that. So let's get right into it. Before I get too far into it, I'm talking about the SKS and SKV, but let's make sure we understand what we're doing. We're taking our traditional KV pump, our traditional KS pump, our vertical inline pumps, and adding a drive to them, okay? But here's pretty much a breakdown of the KV pump, a quick one anyways, and it's a closed couple. So that motor is the impeller shaft, right? And it's a very standard JM frame motor. We offer them up to 60 horse. And I'm not going to get into too many details about my personal recommendations. I wouldn't sell this one above 7.5 or 10 horse. The motor just gets so heavy. But you can see the flow ranges there. And to be quite honest, from a self-sensing standpoint, the KV currently is our biggest seller. I think it's a nice sweet spot for many projects. So keep that in mind. And again, our Taco reps are very familiar with the self-sensing product line. We're going to cover some stuff. I'm going to cover some stuff today, but they have a lot of knowledge about it as well. So please, if you need more information, get in touch with your Taco rep and they can get you more information as well. So then we also offer it for the KS pump, and this is the split couple. Okay, so that just means there's a coupler in between the impeller shaft and the motor shaft. And these bad boys get up to hundreds of horsepower. notice in the performance data, the range goes over 12,000 GPM. I think we even go higher than that now, but they could get pretty big. And we were touring the factory last week with some guests, and we had some big boys out there in the factory that were being final assembled. Actually, a couple were assembled and they were being crated up, and they had 200 horse motors on them, and they get pretty big. But anyways, so these two vertical inline pumps, we now offer them with the drive on it, okay? And there's a picture, two pictures, right? The one in the front is the KV, the one in the back is the KS with the drive mounted right to it. And let's talk about some of the details about the drive. So it's an integrated pump and drive that automatically responds to system demand changes. In our world of HVAC hydronic pumps, closed loop systems, right? Variable speed, and somebody puts a transducer out there, has to run all that wiring back to the drive so it speeds up and slows down, right? Based on the system changes. That you don't need any of that with these drives, okay? Now, I'm not going to do the deep dive into how that all works. I'll explain it a little bit, but nonetheless, they automatically respond to system changes out in the field. So you don't need any remote sensors. That could be a big selling point on some projects. Many of you, I know Rich, my very good friend Rich, has been involved in projects where sometimes the remote sensor isn't installed in the right place, or after it is installed, maybe it has to be moved because of changes, field changes, and that could always cause some issues. Let alone that it's another electrical mechanical piece of equipment that needs attention over time. You don't need that with these, right? So that complex wiring, potentially complex wiring, goes away. So boom, boom. We're talking about, I'm a big believer in simplicity on projects, right? And big believer. I know our business is complicated, and we're designing hospitals and we're designing big projects. But if we can simplify some things, it can help us and the overall project as well. Another nice thing, it's very difficult to see. Where the heck's my mouse? There it is. Right there's a screen. It actually displays flow and head right there, as long as you're in the right screen display. So it measures and displays flow and head for the system. And trust me, I've been in enough mechanical rooms trying to find it, let alone if it's working correctly, the flow meter, or if it's pegged or whatever. So something like that. And the drive is capable, because of its internal smarts and programming and all of the testing that we do at our factory to measure actual system resistance. And we're going to get into that a little more, but think about that. If you're thinking about, most of the time on most projects, right? If you design for 80 feet of head loss, there's a good possibility, I'm talking 80-90% of the time, if not more, that head loss is probably less in the field. Well, here's a big thing here, and we're going to talk about how these drives in our system allows you to take advantage of that, so you can run this pump at a lower speed to actually respond to that. So if you got 200 GPM at 80 feet, and instead it's actually 200 GPM at 70 feet, you can actually reprogram the drive to run it on that system curve instead. And we'll talk about that a little more. One thing that we have done, and the R&D engineer actually just retired, Steve Sullivan, the TACO gentleman, good for him. I hope he enjoys his retirement. He was a little worried about vibration on these drives. So it's hard to see right here, but there's 4 vibration isolators where the drive mounts to that bar that's in the back there. So, and the testing that we did, we're way well below the requirements set forth by Danfoss. And then the system balancing. This is the do-it-yourself system balancing with self-sensing Pro Balance, and I'm going to show you that a little further in the project. So, and again, integrated pump and drive. Now, so there's 4 modes of operation that you can use with this. I need milk and bread. please bring it home. So
Sorry about that.
no problem, Rich. Here's the 4 modes of operation. Variable flow mode, and that's probably 80 to 90, if not more, percent of the projects that we've sold for our SKVs, SKSs, and others, and I'll talk about that as well. But you can also very, very easily put it in constant flow mode. So maybe for a primary, secondary system on the primary system. Constant pressure mode, I'm not sure we do too many of those. I'm not even sure how it would work on a booster system, but possibly for a booster system. And just as important, and think outside the box. I always challenge people to think outside the box. Traditional input mode, meaning you can disable these first 3 modes and accept a traditional signal into that drive. So, hey, let's order. I'm on a project and I'm going to order the pump and drive from a certain manufacturer. I don't want to get involved with the self-sensing, but boom, I got the drive, I got the pump, and now I just put in the sensor out in the system and I can run it that way too. So, you know, I'm giving you opportunities to think outside the box for different types of projects, right? And there's that performance data again. I already showed that one time. And again, this is for the KV, and really this is probably a good percentage, well over 50% of the ones we sell, if not more. Although I'm starting to see bigger ones out there, as a matter of fact. On the SKSs, we offer. It used to stop at around 75 horse mounted to the drive, but I think now we had a project where we're actually going over 100 horse mounted to the drive. When it gets so big, it's just very difficult to mount them right to the pump. I should say, so you would have to mount it remotely. And by the way, you can mount these remotely on a project as well, right? It's just wiring and mounting it. So if for whatever reason it needed to be mounted on the wall or something like that, that can be done as well. Constant flow, constant pressure, automatic response to system demand changes. No remote sensors. I can't emphasize that enough. No remote sensors. A lot of the applications that we're seeing, hot water heating systems, I mean, to be quite honest, it's HVAC closed system hydronics is what it is. Closed cooling circuits, air conditioning systems, you know, water cooled, hydronic heating and cooling, water glycol concentrations up to 50%, solar, geothermal, pretty much the gamut as far as applications go for these self-sensing projects. And again, SKV and SKS. So here's some of the tidbits for these models, okay? KV pumps, you can up to 15 horse can be mounted horizontally. To be quite honest, I don't see that too often, but it can be done, all right? Most of the time, I see them all mounted vertical, right? But you can up to 15 horse mount them horizontally. You cannot mount any of the KS models horizontally. They always have to be mounted vertically. Pumps with smaller motors, I think it's 15 and less, maybe 10 and less, maybe suspended in the piping. I'm going to show you some piping arrangements in a few seconds here. This provided the piping is supported adjacent to the pump. So something to think about or consider there as well. Larger motors, the pump should be attached to a support utilizing the tap hole. So at the bottom, down here at the bottom, there's 4 tapped holes on the casing, right? So you can actually mount the support there, and that's actually an item you can purchase from Taco. So you can, it's just a little stand, so you can mount that there as well. Yeah, and this is for all pumps. Piping load shall not be applied to the pump. I can't emphasize that enough. Shall not be applied to the pump. It's just going to mess things up drastically, right? Pump must be allowed to move with the piping movement. Pretty straightforward there. So do not rigidly connect the pump to the floor. When you put that stand on, you just let it rest there, and I'll show you some of the recommendations for mounting these as well. And this is just a common for all pumps. Always start piping when you start laying out the piping, installing the piping from the pump, and use as few bends as possible, preferably long radius elbows, would be my statement in that regard. And if you're using an eccentric reducer, are used on suction, installed with the flat side down. That helps the flow going in. And in no case And this is very, very important. Do not insulate the motor. So the motor can't be covered with any insulation. So these are very, very important. And like I said, like Rich said, you can download this from our website, excuse me, from today's webinar, so you can have this information. And most of it's in our instruction sheets and available online, but nonetheless, it's probably important to keep these going. So before I get going, Rich, are there any questions out there, or should I just keep going?
So we don't have any questions right now.
Nice, nice. I
Let's
hope they
see.
still can hear me.
I think so. Yeah. So
Yeah,
everybody can still hear us out there.
most of the stuff's been pretty straightforward so far, so I don't think there's much questions required in that regard. So here's some of the recommended supporting and mounting. You can see with some pipe hangers here, mounting that up, right? Pretty straightforward. Hanger supported, pipe mounted. Pretty straightforward in that regard. Pipe mounted, supported at ceiling, right? So you can even see where, this is up off the floor, right? And it's actually mounted up from the ceiling in that regard. A little worried that we're showing the KS pump, but nonetheless, it can be the KV as well. Oop, what happened? Did I do that right? There we go. And there's a discharge elbow for minimum footprint. So these pumps should take up less room in a mechanical room, right? There's that suction diffuser on the suction side, right, with the straightening vanes in it. And then there, if you get that, you got a discharge elbow on it, and you can go straight up and hang it like that. That's a pretty neat package as far as I'm concerned. So something to consider in that regard. And by the way, the Taco suction diffuser, please make sure you're familiar with these. They're there. It's a strainer, right? There's a strainer in there to pick up a last resort of big stuff before it goes into the pump. But the Taco suction diffuser has a startup strainer in it with a very fine mesh screen. And after the system is started up, and I don't care if it's a vertical pump or a inline pump, a base mounted pump, that startup strainer needs to be removed after the system is started up. It's in the instruction sheets. I say that enough, but nonetheless, just keep that in mind. And then here's some with, you got some pipe supports, right? Holding those up as well. And then look at the pipe hangers up here, lifting that up as well. A lot of this information is shown in our literature and documentation, but since I'm trying to do a deep dive, I'm trying to show it to you as well. Here's some more.
Brett, we did have a quick question.
Awesome.
So I'll read it, and then we can figure out what the answer is. What's the maximum distance the drive can be placed apart from the motor?
That's a great question.
That, I can offer some guidance on that. The distance is actually governed by the National Electrical Code, and I believe because the drive is a disconnect, it has to be within line of sight. So you have to be able to see the drive if you mount it remotely, and then the actual distance is also governed by the National Electrical Code with respect to change in wire size. So we don't actually publish that data because it's covered by the National Electrical Code.
And it's very, very, very important that you use the correct wire, the same wire that we send it out with. That is very important. It's whatever it is, it needs to be identical to that. So that's critical when you do that. So great question, though.
Good question. Thank you.
Yeah, I guess you don't want to mount it in Rhode Island and have the project in Massachusetts. Is that what you're saying, Rich? That's a little too far.
I would tend to avoid that. Although, it depends. I mean, you could have a building that's on the state line, right?
That's true. That's true.
Yeah,
there
half
are
the mechanical room is in the Rhode Island, the other half is in Massachusetts. But that would be pretty rare.
Considering Rhode Island's only roughly 45 miles by 35 miles, with a big body of water almost in the middle of it. Not quite the middle, but anyways, nonetheless. Here's some other potential ways to mount these guys as well. These guys, you can see some pictures here, and that's some ideas there as well. With stanchion plates, there's all different ways, right? We used to offer these, but we don't anymore, but they can be fabricated. And we have seen some people put these on seismic projects as well. And I think out in California, we actually got it's rated. There's some rating out there. I know my good friend Ben Needham was working on something to get that taken care of out there. So that for the folks in California, make sure you talk to your TACO rep so you can get the more details on that as well. Groove piping is fine. You can see we got a little stanchion in here to move it out as well. So here's some of the installation requirements that are shown here, torque requirements. I'm not going to get into that, but for the different motor sizes, the bolt sizes, and we actually have some torque specifications. Don't let that out of the bag. Some of you might know. Anyways, and then the bill of material is shown here for all of that as well. So it is pretty important and critical to make sure everything's properly taken into account in that regard. And see number 4 here is the vibration isolation mount, and that's right there. Number 5 is actually a safety strap that's shown there as well. It's a little difficult to see in greater detail here. God, it's very sensitive today, very sensitive. Stop being so sensitive. But you can see that in some of these pictures here as well. Do not, don't use a lifting hook to lift that drive or motor, please. Motor lifting hook supported. Don't do that. Don't do that. And then mount it on rigid base without flexible connectors. You can't do that either. You'd have to have flexible connectors here to allow that to move. So some of the things you want to talk about or take into account in that regard. So I did want to at least show you some of the other offerings that we have for the self-sensing models. So we haven't forgotten about the base mounted or the foot mounted over here. Most of them are these SKS and SKVs, excuse me. But you can order the CI, which is the foot mounted here. That's our closed coupled foot mounted one, or the FI, which is our base mounted pump. These drives do not mount directly to the pump, so they do need to be mounted remotely, but nonetheless, we do offer them for our horizontal pumps, these as well. I don't think we've sold them for any of the split case, but if you, I'm sure if you had a project with 300 on there, I'm sure we would do it. Quantity 300, maybe a little less than that, but nonetheless, that's probably getting a little outside the realm here. So let's get into the drive a little bit more and what comes with these drives when the project is shipped, because this is very important. This is very important because sometimes this bag gets thrown out and you have to call the factory and get another bag sent out, and that's not good. So there is an accessory bag that comes with these, with the IOM manual and some hardware, as well as the instruction manual for this FC102 drive. So it's very important that somebody with somebody on the project takes hold of those bags and keeps track of them, because it has a lot of information as well as some stuff that needs to be put into the drive. So just keep that in mind. And here's the control terminals all broken out. And I'm not going to go through them all here, but you can see they're all numbered inside of one of these pieces right here, right? And then there they are all listed up here. And that's where you start wiring to the drive. Depends on how you want to set it up or whatnot, or accept some external signals, or to read to the BMS system. So you can do that as well. And then there's actually some potential for parallel pumping. For alternating pumping. So let's say you had 2 pumps and you want to alternate them, right? You have a backup, or 3 pumps and you want to alternate them. So you can do that as well. But you'll see some of those photos as we go through this as well. Whoop, 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 whoop. Where am I going? All right, so here's a very important slide, another very important slide, pre-commissioning checklist, okay? Before you start starting this up, our technical service team makes sure or demands that this is done first, right? So install the pump and wire the drive in accordance with the IOM, right? So boom, first you got to do that. Pretty straightforward. That shouldn't be hard to do. Fully purge all air out of the system, right? If there's air in that system, it is going to cause problems for the pump slash drive once it starts to try to settle in and get started up. Install the terminal blocks included in an accessory bag for future use. So don't throw the bag away. You know, you got to take the box out and install them in the drive, right? You open this up and put them in. It's pretty straightforward. Rich has a funny story about pump rotation on one of these drives, but check pump rotation. You remember that story, Rich?
I don't know if I remember the actual story.
It was our one of our favorite reps had a
Oh yeah, yeah, I had a demo unit.
demo unit, and they were running it and teaching people and all that.
Yeah, and the pump was running backwards for like 4 years and nobody noticed it. But the funny
I'm not
part
gonna.
is that it wasn't running quite right, but they didn't know why. Anyway,
I'm not going to mention the rep's name because he's a very good friend of mine, and he may I think he had actually signed up for. Oh, maybe he didn't, but anyways. And then when you go to start it up, you got to open all the valves, excluding bypasses, to replicate full load conditions. So let's think about this a little bit, right? We order our pumps with this drive based on a flow and head, similar to you do a regular one, right, without the drive. So I'm going to make up some numbers. 300 feet at 300 GPM at 50 feet. Okay, so that's what you order it at. Well, we want to make sure that the system is running close to that 300 as maximum flow. All right, maximum flow, full load conditions. We're going to talk about the head loss or the system resistance shortly, but nonetheless, in order to properly start this drive up, you want to make sure you're able to do that. So don't try to start it up early without being able to get to the max. That's just some friendly advice, and trust me, it happens. I think we all can understand that as well. So here's just the LCP display. What's that mean, Rich?
local control panel.
There you go. I like that. I was all wrapped around the exit, and I knew that, but us old guys, we forget things every time you wake up in the morning. Anyways, this is just a picture of that local control panel in one of the screens that you can see there. And this one here shows the GPM and happens to show amperage, and it's in feet up here. It's all zeros right now, but nonetheless, you can see some of their status, quick menus, main menu, alarm log. That's why it's so important to keep those, to keep the information that comes in that bag, because a lot of that has to do with how you utilize all of these buttons and screens and whatnot. So just keep that in mind. So here's your different program modes. Okay, and this is setup one. That's pretty much the most one. That's how most systems work. That's variable flow, whatever flow compensation, whatever you want to call it. That's the method that assimilates or is very similar to accepting a signal from a remote sensor. Okay, and that's pretty much, if you think about it, that's how most pumps are run in the field, right? So flow compensation. So that's setup one, right? Pretty straightforward. You do that, you set that up under the quick menu, and you're able to get to that. Constant pressure, and I'm going to show you another screen about that. That's setup two. Also setup one, but it's a different part of that screen. Alternation standby is setup two. BMS control is also setup two. Constant flow. That's probably the second most, well, maybe the transducer input one is the second one most used, believe it or not, but constant flow would be setup screen 3, and that's maybe for a primary system. If you think about it, right, if you got a primary chiller that needs 1,000 GPM, boy, you set the drive to you're going to get 1,000 GPM on a consistent basis. That chiller is going to be very happy. If you ever sat through one of Rich's classes, that chiller is going to have the smiley face when he's doing his primary, secondary discussion. And then setup 4 is where you can override all of the other ones and accept the outside signal. I do want to make sure I challenge you folks to think outside the box a little bit. Again, right? That's the 10th time I've said that this presentation. If you ever are going to get involved in specifying a self-sensing pump, make sure the whole team understands that, because we have had situations where not everybody realized on the project that they didn't need the transducer mounted in the wiring. And so all of a sudden at the end of the project, hey, where do I wire this? Wire it in, and they're planning to use it because maybe the control guy or whatnot didn't communicate. So just keep that in mind. If you want to utilize the self-sensing and get the 100% of the benefit of it or potential benefit of it, you want to make sure that the whole team understands that, so they don't put in the transducer and do all the wiring and whatnot. So that's really something to think about in that regard. So Rich, I'm going to take a break and have a sip of water. And any questions, or is it?
Yeah, we did have one question. I'm not sure I understand the question. I'm going to read it, and then the person that made the or asked the question, I think the name is Alfredo. Question is, can the frequency converter be added to the KVKS pump in parts? I'm pretty sure the answer is no, but I'm not sure what they're referring to as pump in parts. Maybe you have a better idea, Brett.
If the question is referring to doing it after the fact to an existing or after the pump leaves, the bottom line is the pump and drive have to leave the factory together. So there's no parts involved, if you know what I mean, right, Rich?
Yeah, and so maybe Alfredo could maybe elaborate a little bit on what that question means.
At the factory, we actually test the pump with the drive in one of our test loops and map all of the over 100 different. We use speed changes and flow and head changes and put in a bunch of curves or points into the drive. So that all of that information is already in the drive, and that drive goes out with that pump. So just keep that in mind. And that, there's no after the fact with different parts. So I'm not sure if we answered that question, but I can't emphasize enough that the pump and drive leave the factory together because all of the programming's in there. And by the way, it is a Danfoss drive. I don't know if I even showed that picture on way back here. Sometimes I can see where it says it. Does it say it on there? Anyways, it is a Danfoss drive. It's their intelligence that we utilize for this. So keep that in mind. So flow compensation mode, variable flow. So you select auto on and observe. So boom, you got the pump running at full flow rate, and it's supposed to be hitting at certain point on it to hit your design and flow set point. So you see how the system's running. And actually, once you get familiar with these pumps, there may be a possibility that the startup and balancing of the system might be a little easier. So we'll see if we can talk you into that, right? So it's pretty straightforward, and if you observe the system while you're watching it, right? And then what happens is most of the time you end up running out on the curve because there's not enough head loss, right, in the system. Actual unbalanced operating point exceeding design flow. On site, the pump is oversized, too much flow. That's what it seems like, but that's because your system resistance is now further out on the curve, okay? The original design curve is at point A, and now the pump is trying to run at point B. So that's not where we want it to run because you're too far out, right? You're getting, instead of that 300 GPM, maybe you're getting 400 GPM, and that's not good for the system. So you put the system in constant flow mode. This is part of the pro balance. You put the drive, excuse me, not the system, but the drive in constant flow mode. All right, and I mean, it sounds a little complicated, but it's really keystrokes on that LCP pad, following the directions that are written out. And many of our reps have done this, so they can actually have someone from their company or whatnot. And actually, I have had projects where the folks have called our technical support. And by the way, we actually have, during normal business hours, a person that answers the phone at Taco. What? I'm telling you, there's a person. Carla. She answers the phone. A person actually answers the phone at Taco. Anyways, and you can call technical support, and they can walk. They have walked through people through it as well. But anyways, once you do the right keystrokes, you put it in constant flow mode and say, I want to run it at 300 GPM, and you let it run for a little bit, and the system is going to display on there the actual head loss of the system. All right, so in my example, it was 300 at 50. Maybe it's running in at 300 at 40. All right, so you remember that information, and now what you do is you put it back into reset the control curve by putting, you adjust it through the keystrokes, 300 to 40, you adjust the curve, and now you're going to operate, the pump is going to operate at a lower speed to operate on the most efficient curve, okay? And it sounds a little hunky and horky and whatnot, and maybe I'm not explaining it that good, or whatever you want to call it, but nonetheless, that's what you do. So, you know, we know we're out too far. We put it in constant flow mode, back to the flow rate we need, right? You've designed the system, or somebody has, it's on the drawings. You want that pump to run at 300 GPM, 100 GPM, 200 GPM, 1000 GPM, whatever it is. Let it run in constant flow mode, and it's going to show you on the screen what that head loss is actually for that system. And then you take it out of this mode, right? And you reset the control curve again with some keystrokes, so you're actually running on the adjusted control curve. And you know, these are it's kind of showing a little small curve here, but nonetheless, that is going to give it the most efficient operating point, and the system's going to be very, very happy in that regard. Another smiley face, Rich, another smiley face.
Smiley faces to go. We do have a quick question.
All right, great.
And I have a quick answer. Does TACO retain the drive data for each drive pump in case of replacement is required? And the answer is yes, we do.
We do.
And the second half of that question is that if you go through the IOM manual, one of the first things that the IOM manual recommends is that you create a backup file, which you can do. You can either put the backup file on your computer, or you can save the backup file on the actual LCP, so that if you
Nice.
get the file gets corrupted for some reason, you have a replacement file.
I mean, I think in my simple opinion here, I would still want to back up 2 pumps. You know what I mean? If it's a simple system, you still want a second pump with the drive, right? So in case something happens to one of the pumps, you got the other one to back it up, right? And I'm not talking about parallel pumping or anything like that, but nonetheless, it is good to know that you can create your own backup file, or TACO has that. We have that information at the factory based on the sales information associated with it. Great answer,
Yeah,
Rich.
and if you, like you said, Brett, if you ordered, say, 2 pumps, for example, and one running, the second one standby, uh, the file would be the same for both pumps. So by default, if you have 2 pumps, you also have the file to operate the pump in the second pump.
Nice.
Nice. Kind of cool.
Constant pressure. Here's the simple, not the simple, but the programming that needs to be done. Active setup 1010, right? Program set point 2021. These don't mean a lot unless you're right in front of the LCP, but it's pretty straightforward. It has to be, because I was able to do it. and then you disable flow compensation. You get to 22 and you hit 80, and boom, you do that, and now you're going to be in constant pressure mode. Again, I don't know, Rich, if it would even work on a booster system. You know, I don't think we've ever sold one on a booster system. Do you know if we have?
I don't have any firsthand knowledge as to
Yeah,
whether or not someone's using it in this mode.
I'll have to ask maybe Tom, so one of our tech support guys, next time I see him in the house. Actually, I'm going to be at the factory tomorrow. I'm going to pick up those 2 pumps and bring them to the factory tomorrow, Rich. But anyways, that's a different conversation. Here's that constant flow mode. So these setups, and look, there's only 2 setups here in order to put it in constant flow mode, and that's part of that do-it-yourself pro balance, whatever fancy names you want to call it. But it really is pretty straightforward. But I think all of us can see how that can do that, right? If we put it in constant flow mode and we ask for what we wanted for design flow, and if once after it settles down and runs for a little bit, it's going to show you on that screen the actual head loss that it's running at, the system resistance that it's seeing out there. Now, I will warn you, you got to make sure that number isn't really out of whack, because if it is, maybe it's not running, not everything's on or something like that. But nonetheless, you can see some of the advantages there as you go. So something in that regard. Alternation. So this is like we were just talking about having a backup pump. You can also do some wiring and active setup. You know, I'm not going to get into these too much, but nonetheless, it'll alternate, right? So you run pump 1 for 3 days, and then you run pump 2 for 3 days, and you know each one's a backup to the other. But that way, you're helping the longevity of both of the pumps. So you can do that with this drive as well. Pretty straightforward. I don't think anything that I'm mentioning here is way out of whack in that regard. But nonetheless, you can do that as well. And the last one you can also do with some is BMS speed reference. So you can send the information back. It's a one-way street, though, I believe, Rich, right? For our BMS, we can see the information, but I'm not sure. I don't think we can send much signals to the drive.
The only thing we can do is, as shown on your diagram here, the start-stop from an external source. So
yeah,
you're right.
so,
We can only read the data. We cannot write to the data.
Yeah. So most of it is reading only. So very little going out from the office or whatever. But nonetheless, you can do that in that regard. I hope there's some more questions. Well, maybe not. Maybe these guys and gals can get off the thing real quick, because wait till you see the next screen, Rich. Whoa!
Whoa! Look at that.
I don't even know if that's legal, this screen. I don't know. I might get in trouble for that.
I don't know. It looks like a legal screen.
Yeah, who knows? But so anyways, I have reached the end of today's thing. Unless somebody wants to start asking some more questions.
Yeah, do we have any new questions out there? There was one question. I'm pretty sure you answered it. I'll just kind of read it. Read it? Is that regular English words? Read it? Read it.
Read it, read it. Yeah.
Read it, read it. Okay. It says, will you be going over how to select the 4 different types of operating modes? And I think you covered that. So
yeah, I mean, it's relatively some keystrokes. I think what I didn't do, though, and I apologize, is I didn't show you how to override to get to which one was it? Transducer input, but that would be in setup 4 if you wanted to override all of the automatic modes of operation and just accept the signal from there as well in that regard.
So here's a question that was not posed today. It was not on the question list, but it comes up periodically, and I'm going to ask the question and then answer it. The question we get periodically is, where is the pressure sensor? And the answer is, there are no pressure sensors. It's all done with software.
Yeah. And it actually does take a lot of work at the factory. You know, we need to map out all of the information, and so now the drive has the ability to it knows its speed, and it knows its what's the current, and because it knows those data, and that's part of the information that helps make the curve, it can stay on those curves. So that's how it does it. And there's programming involved in that regard. So in that regard, that's a great question that Anthony just asked. Can pro balance be done with transducer input? No, I don't think it can be, right? I think it's only self-sensing.
That's correct. Yes, if it's an external signal, it ignores all the software for self-sensing functions, and it just looks at the input signal from a 0 to 10 volt
Yeah.
or a 4 to 20 milliamp signal.
Yep. And then replacement drive, we do have replacement drives. You know, oh, excuse me, we don't have them, but we can get them. Well, but I do know there are some reps out there that actually when they sell a vertical pump now, they quote it with the drive mounted, even if it's not even if the drive is not being used as a self-sensing drive. They want to have all that responsibility, and they think it's a better project when it's like that as well. So something to be guarded. And I think my friend Darren, I see a thumbs up from Darren, so he might be one of the reps that does that. If he's still on, I don't know if he's still on or not. He could be gone up in Canada. My good friend up in Canada. But other than that, Rich, I am all done. I know we're done a little early here, but I guess
Yeah, we don't
early is
have
better
any.
than.
Wait a minute. Nope. That was just someone saying thank you. And you're welcome. We don't have any new questions.
Mark is very thoughtful, because he says thank you almost every one of our Takeo Tuesdays. So I think he listens and stays to the end. What do you think of that, Rich? That's pretty good.
Yeah.
Anyways, don't forget to tell him about Mark's with BJ Taroni, one of our best reps down there in the Philadelphia area.
Philadelphia. How do you say that? Philadelphia. Is there another pronunciation for the? Oh, Philly. I guess people will just say Philly, right?
Yeah, with the cheesesteak, Philly cheesesteaks.
Philly cheesesteaks.
Anyways, I hope everyone got something out of it. I tried to cover as much as I can. The slides are available. If you have any other want any more information on it, talk to your Takeo rep. And other than that, Rich, don't forget to tell them about the PDH thing about tomorrow and all that. Yeah, I'm done.
Yeah. So roughly 24 hours from now, you'll get an email saying that you can download the recording. We made a recording of this, and you can also download a certificate that said that you participated in the presentation, and you can use that for professional development hours. And so I think other than that, I think, well, we'll just mention one more time. I think we covered it a couple of times. There is a download of this presentation, correct, Brett?
Yes, sir.
So between the download, the recording, and all the other information that Brett provided, you should have lots of stuff to read over. So at this point, I'm going to ask Brett to sign off, and then after he signs off, I'll sign off, and then we'll move on to, maybe we'll have some lunch. I haven't had lunch yet.
I challenge some newbies on here for self-sensing to give it a shot. I do know that a lot of folks that have tried it, you know, sometimes you hear sales pitches on different things, and I know in our industry, changes are sometimes difficult to go with, right? That's why base mounted pumps are still sold on a daily basis instead of the vertical inlines. But nonetheless, I do know, based on some personal conversations with some folks that gave it a shot and worked with their rep the first time on a project, and some of the ease of it, and what we said and what we advertise and what is advertised about this product. And again, we're not the only ones that offer it. It's true. So something to consider. So other than that, Rich, thank you everybody for your time. Back to you to say goodbye.
Thanks again, everyone, for taking time out and participating in Takeo Tuesday. We look forward to the next one coming up in a couple of weeks. So I'm going to say sign off for now, and thanks again for participating. Take care, everyone.
Bye, everybody.
Bye-bye.